Hi, hello everyone. A big hi to all my bacha log. Now, before starting with anything, I just want to ask you, are you all ready to give the best preparations in today's class, okay? And to learn the complete chapter for the term one examination. Are you all ready? If you all are ready, then stay here because in today's session, right, starting from 3 p.m., we are going to complete the entire syllabus for this upcoming term one examination. So, bacha log, let me say hi to everyone here in this classroom. So hi Deepa, hi Raki, Nivink, Pawan, Vimla, Hidesh, Shivang, Abhilasha, then the Beast Gaming, Sneha, Lakshmi. Okay, so a big hi, a beautiful hi to all the bacha logs here in this classroom. Nancy, the Beast Gaming, Vaishnavi, tell me how many of you came prepared? Dekh le, I bought 2 bottles of water, right? One is from here and the other one is here. So I'm totally prepared. So tell me how many of you also came to the classroom with full of preparations? Hi, Beast Gaming, Myara, Vaishnavi, good afternoon. Myara, I'm doing so good. Anjali, hi. Dileep, Kriti, Vidhi, Raki with full preparations, right? Okay. So I think you all came, matlab every bacha log in the classroom came with full of preparations, hai na? Because let's complete this particular marathon series with a beautiful smile. I know that it's going to take time, right? So don't worry at all because after this session in today's class, right, we are going to grab that 35 out of 35 in the upcoming term 1 examination. So, bachalo, whoever is seeing me for the very first time, this is Ameer, your physics educator at Unacademy, and a bit of introduction about myself you all can see on the screen here. Okay, I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board student. BTech graduate from NIT Calicut in mechanical engineering, and here I am. One more thing, mera bacha log, I'm from Kerala, so I don't know Hindi much. So basically, all the conversation and discussion about the topic will be in English. Fine, but बीच में थोड़ा थोड़ा हिंदी में भी बातें करेगा. बातें करो, मुझसे बातें करो. So this is what we are going to do in today's class, which is 8th of December marathon. We started with our first lecture, which is Electrostatics and Current Electricity. 7:30 we'll be resuming with Magnetism chapter, and at 10 p.m. EMI and AC. And after that, yes, we are totally ready to go with for the term 1 examinations, isn't it? Yes. Moving on, bacha log, if you don't want to miss the live classes from any of your favorite teachers, be a part of this Telegram channel. The link is given right here and in the description box. ठीक है? Bugs Bounty क्या होता है बच्चे लोग? It's an amazing way which can help you to grab prices. What do you have to do? Go to the description. There you'll find a form. If you're finding any inappropriate content in the videos uploaded by Unacademy, right? And if it is valid, you'll get so many prizes. Now, before I start with the session, I want to ask a small favor, not just to myself, mera bacha log, to all your friends. What is it? Tag this and share this class to all your friends and ask them to join the class as soon as possible. It is very important, right? Because let's all learn together, because I want everyone whoever is here in the classroom to get that 35 out of 35 marks. Milna hi chahiye, because we are spending time, we are studying together, so we want to get it. So jaldi se, theek hai? Hitesh, Rose, Jatin, Shivang, Anish, Atiba, Yash Raj, everyone, right? Everyone share the class to all your friends. Now we have 74 live students. Everyone, if you all take a friend, let it be 150 students, right? We all can learn together and make this awesome. So regarding the plus subscriptions, so in the plus subscription, the most amazing feature is that you can clear your doubts on the spot. Okay, let's say you're coming to the Unacademy Plus platform and you're having doubt when a teacher is taking classes. So what you can do, there is an in-call class feature where you can call the teacher at the moment and clear your doubt. So learning something without having any doubt, isn't that the dream of all the students? And this dream is only possible once you're a part of Unacademy Plus subscription. More than that, we are having educators, top educators of the country who's having a very good experience in the field of education. They'll be telling you what to study, what not to study, what are the multiple choice questions as you should be practicing. Everything they'll be there. You just want to follow them. You're going to ace in all the competitive examinations, whichever you are dreaming about. Then study materials will be given, practice test, live test series. You're going to be super duper amazing, and your progress is something which you all can be assured about. Now for this, if you're going for 6-month subscription, it will cost you 1,667, but the entire physics family have this code, which is AMB10. Use this code, get 10% of discount, and you'll only have to pay 1500 then for the same course. ठीक है? And maximum offers while you make the subscription. ठीक है ना? Amazing thing, right? और क्या? Then Iconic. In Iconic, you will get all the features of plus subscription plus some extra features, such as you will be given a personal mentor, someone to look after your academic activities throughout 24/7. This person will be there, and you'll feel so much comfortable when this person is assigned to you related to your academic things. Okay, live doubt solving classes, weekly reports. For all these useful and very good amazing features of Iconic, if you are going to enjoy this, I think 6 months is enough. Why? Academic year and we are almost are, so it will cost you 2,833, and then you will be applying the code for our physics family, which is AMB10, and then you'll only have to pay 2,550 rupees, and more than that you'll get maximum offers while you make the subscription by using the code of AMB10. Fine, now that's it. It's time to get started with the very first chapter. Tell me, okay, are you all ready for that? First, I'll tell you how the session is going to be, right? Okay, and then I'll be telling you from where you'll be getting the notes. I'm going to tell you everything. First, tell me, are you all ready? Palak, ready? Ritu, hi. Shavra, Jatin, Tibe. Okay, first class, Jeet, let's see how it goes. Okay. Sir, I'm not confident enough. After today's session and after you attend all the lectures, you're going to be super confident. Than me, you'll be super confident in physics. Okay, but chalo. So with your yes, we're going to start our session. Now, everybody listen here. How the session is going to be. We'll be discussing the main definitions, right? The very important formulas, okay, of all the chapters starting from electrostatics till EMI and AC. Okay, that is what we are going to do. Now we'll be asking, sir, do you have to write the notes? Depends on you. If you're very good at writing all the notes very fastly, you can do it. Else, no worries, because I'm going to provide this PDF in the Unacademy Class 11th and 12th Telegram channel just like this. So you can use this PDF as your short notes and you can revise the same in for tomorrow also, just before you go to your exam hall. Okay? So I'll be providing the notes in the Unacademy Class 11th and 12th Telegram channel. The notes of all the chapters will be there. Okay? So be right there so that you can get the notes. Fine. So let's get started, mera bachalo. So we are with the very first chapter, electric charges and electric field, and there it's starting about charges, right? Let's go with the properties. What are the properties of the charges? As we all know, we have two types of charges, positive and negative, right? Two like charges will be repelling and unlike charges will be attracting each other. Not spending much time on that. Moving on. Now, regarding the properties of charges. What are the properties avoided by these charges? First one. 1 minute. Okay. Regarding the properties of charges. First one, additivity of the charges. Charges are completely scalar. So if you want to find out the total charge present at a particular point, you just have to add the values just like a scalar number. Just like you have 1 coulomb, 2 coulomb and 3 coulomb. Someone is asking you what is the total amount of charge. Minus 4 coulomb volt. So what you have to do? 1 plus 2, that is 3 plus 3, 6 minus 4, that is equal to 2. You just have to add the numbers just like you add any two numericals or three numericals numbers. Bas. Okay. Then second property is conservation of charge. Charges are always conserved, mera bachalo. Though charges will be transferred from one body to another body, charges are always conserved. Dekh le. You have two identical spheres. In the first sphere, let's say a charge of Q is there, right? Here the initial charge was 0. Okay. Now you connect these two spheres by a wire. What happens? The charges will be distributed equally between them. What was the initial charge present on the entire system? Q plus 0, it was Q. After the charges were distributed, how much is the total charge present? Q by 2 plus Q by 2, that is Q itself. No change. Okay. So charges are always conserved. Fifth, quantization of the charge. Tell me how a body is able to acquire some charge, either by the loss of electrons, either by the gain of electrons. Electrons can be gained as 1 electron, 2 electrons, 3 electrons. Matlab, the electrons will be gained by a body as an integral value of electrons. Hai na? So the charge that is obtained by any body will also be an integral value of electronic charge. What is the basic electronic charge? 1.6 into 10 power minus 19 E value. So the charge possessed by any body will be equal to an integral value of the electronic charge, either 1 time 1.6, either 2 times, 5 times, 10 times, 100 times. We cannot have a fraction along with the electronic charge when we find out the charge present in a body. Fine. Clear till this part? It's very simple, I suppose. Okay. So like I said, those are very fast at writing down the notes. You can do that. Else no worries. I'll be providing you the notes. Then materials are divided into 3. Which are the 3? Conductors, insulators and semiconductors. This we will not be discussing at this particular first part of the book. We'll be having this at part 2. Mainly here about conductors and insulators. I think you don't need a definition. That which conduct electricity is conductors. That which do not conduct electricity is insulators. Fine? Okay. Which are the methods of charging a body? We have 3 different methods. The first 2 methods are used for charging conductors and the last one is used for charging insulators. Right? You all know how to charge an insulator with the help of friction. Right? A glass rod. Okay, a glass rod and a silk cloth. Right? If you rub both of them, the electrons will be transferred from glass to this silk cloth, which makes the glass rod as positive, right, and this silk cloth as negative. We all know this. This is how we transfer the charges between insulators with the help of friction. Then conductors, there are several methods, or let's not say several methods, 2 methods actually. First one, by conduction. Dekh one conductor, like we already have discussed, if it has a charge of Q, you want to give some charge to the other conductor. What will you do? You connect these two. So the charges will be transferred from one body to another body with the actual physical contact until both attains a common potential. Right? This is what? By conduction. Next, the first one, which is induction. How it is? This is the method of charging a conductor without actually touching them. I'll give you an example. 2 isolated sphere. Near to that, you are keeping another material, let's say of some positive charge. What will this positive charge on this particular rod will do? This positive charge will be attracting the negative charges on the other sphere, right? Okay, and it will be repelling the positive charges here to the other side of the sphere. So you can see that on the first sphere we are having negative charge, and on the second sphere we'll be having the positive charge. So just separate them. So you'll be getting a sphere with a negative charge and the other sphere with a positive charge. So this is a method of charging a conductor with the help of induction. Clear till this part? This is the basic things mera chalo. ठीक है? Clear? Okay. Fine. Okay. So Telegram link is at the bottom. Unacademy class 11th and 12th Telegram link is there in the chat, matlab in the description box mera bachalo. Yes, Rakhi, Deepa, Sudeep, Shraddha. Fine. Okay. So I hope the speed is fine for every one of you. We'll be going with the same speed. Fine है ना? सब लोगों को follow कर सकता है. Yes, Kriti, Abhilasha. Okay. Okay. Very good. So we are going to move further. देख ले. Coulomb's law, which talks about the force that is acting between two charges. Everybody knows, है ना? We have a charge Q1, let's say. We have another charge Q2. Distance between them is R. What is the magnitude of the force acting between them? K Q1 Q2 divided by R square. Where this K, how will you define the value of K? That is equal to 1 by 4 pi epsilon naught. Where 1 by 4 pi epsilon 0 is having a value of 9 into 10 power 9. You'll be asking, what is epsilon naught? Epsilon naught is the permittivity of free space, which is having a value of 8.85 into 10 power minus 2. Now, Again, बच्चा लोग, a few more clarifications. Now here you will be using 1 by 4 pi epsilon 0 when these two charges are kept in vacuum or air. ठीक है? If you are keeping it in some other medium, the value of this k will be equal to 1 by 4 pi epsilon. What is epsilon? The permittivity of the medium in which these two charges are being kept. Fine. Note all these things down. These are very important, right? Okay. Now this is about the magnitude, and because we very well know what is the direction of the charges, है ना? Because both of them are positive, it is a repulsive force. One is positive and the other one is negative. Along the line joining them, it is attractive force. We all know this, right? Nothing more to discuss about this. Matlab, finding out the direction, we very well know that this is the equation of force. These are some extra informations while we use the formula of Coulomb's in finding out the force existing between the charges. Fine? All good? Okay. Now we just proceed further. Coulomb's law, all these being discussed right now, right? Okay. Now superposition theorem in Coulomb's law. What is it? देख ले, we are having a charge of Q. Question is to find out the total force acting on this charge Q. Total force. If it is only one single charge surrounding it, you can simply find out the force acting on this Q. We'll say F1, right? Okay. As force is a vector, F1 vector. It's very simple. But let's say this charge Q is surrounded by more than one charge. Let's say here we have Q1, here we have Q2, and here we have Q3. In this case, how can we find out the total force existing on this particular charge Q? Method. Find the force 1 acting on Q because of Q1. Then separately, we will find out the force 2 acting on small q because of Q2. Then separately, you will find out the force 3 acting on Q because of Q3. Then you will add up all these three forces vectorially, which will give you the total force acting on this small q. That is the superposition theorem of Coulomb's law. Fine, nothing more important, not so difficult, because you all know regarding the concepts of vectors here. है ना? ठीक है? Okay. Moving on. Now the first part, let's say the first part of this particular chapter is almost over. Now we are entering into the core of this chapter, which is electric field. What is electric field? Very simple. The simple definition. What is electric field? देख ले, you are having a charge q. The space around the this particular charge, can you see? This space around the charge is simply defined as electric field. That space we call it as electric field. Now, what is this E? E is not electric field, it is electric field strength or electric field intensity. वो क्या है? What is electric field strength or electric field intensity? That is the force experienced by a unit charge kept at a point. Okay, the force experienced by a unit charge kept at a particular point is simply called as an electric field, right? If you want to make a small derivation for that, we can do it. देख ले, we have a charge q, right? At a distance, we are having another small charge q naught. What is the force existing between them, bachalo? K capital Q small q divided by, let's say the distance is r. Isn't it k q by r square? है या नहीं? हाँ, बिल्कुल. ठीक है. So how is electric field defined as? Electric field is defined as force divided by charge. So from F, if you cancel this q, what is the formula? K q divided by r square. So matlab, if you are having a point charge of q at a distance r, the amount of electric field it produces k capital Q divided by r square. Very simple. So we just have proved what within some seconds, है ना? The value of electric field by a point charge kq by r square. Question: vector, scalar. Electric field, is it a vector or a scalar? It's a vector quantity, because electric field vector is equal to the force vector divided by the charge. What is its direction? The direction of force experienced by a positive charge. Whatever is the direction of force experienced by a positive charge, that itself is the direction of electric field. ठीक है? No problems at all. Shall we proceed? ठीक है. One more thing. ठीक है. But चलो, sometimes in the question they'll be giving you an electric field, right? the charge will also be given. Question can be, what is the force acting on this particular charge? How will you find out? Alright, just look into the equation. Force F is equal to, what's the formula? F is equal to Q into E vector. These kind of questions also you can expect. This is very important. ठीक है? Proceed कर सकता है? हाँ? Okay. Electric field due to a point charge, just now we have discussed, हो गया हमारा. Now electric field intensity, that's what we were discussing till now, वो भी हो गया. Now properties of electric field, just like we were discussing the superposition in Coulomb's law, same thing applies here. मतलब you have a point P, let's say. Here you are having a single charge of Q1. Someone is asking you what is the electric field at the point P. What will you do? You will find out the electric field at this particular point P produced by Q1. It's not a big task, है ना? ठीक है. Now let's say the point P is surrounded by Q2, Q3 also. Now the question, same question. What is the value of electric field at the point P? What do you have to do? You have to find out the electric field produced by Q1 at the point P. Then you will find out the electric field produced by Q2 at the point P separately. Then you will find the electric field produced by Q3 at the point P. You all have all the three electric fields, है ना? Just add all the three vectorially at this point. मिल जाएगा आपको आंसर. और क्या? समझ में आ गया? समझ में आ गया? So first chapter you must be very a bit cautious because electric field and force are vector quantities, but once we jump to the chapter of potential, it's a scalar quantity, so it is, you don't have to take care of the directions there. Okay? So we're going to proceed further. Now by using the concepts of electric field of a single point charge, here we have derived the electric field produced by, use another color, okay, a ring of charge. Matlab throughout the ring, which is having a radius of r, we are distributing a charge of q here. So question is, what is the value of electric field at a point P which is at a distance of x along the axis? Can you see? An axis is being drawn from the center. This point P is at a distance of x. Question is, what is the value of electric field? Formula 1 by 4 pi epsilon 0. ठीक है? Q, the charge, x is the distance along the axis from the center to the point, whole divided by r square plus x square, the whole raised to 3 by 2. Very important. This exact equation is given in your NCERT also, so by heart it questions can come directly. ठीक है? Okay. But chalo, can I wear my chashma? Oh, I have to clean, I suppose. Okay, so बच्चा लोग हम move कर रहे हैं. Now can I ask you a question, बच्चा लोग? Tell me, what is the value of electric field at the center, at this point O? We'll put it as O. Who can tell me what is the value of electric field at the point O is going to be? Anyone? Can anyone tell me what is the value of electric field at the point O going to be at the center? Can anyone tell me the answer? Anyone? Arey baap re. This is the amazing thing about all my legends here in the classroom. Yes, Shraddha, Abhilasha, Nivek, Ritka, Hype, Shivang, Nivek, Abhilasha, Pragya, Himanshu, Arohi, Sudeep, Hidesh. Very good. It's 0. Why? Bachcha log, why the electric field at the point O has to be 0? Because this distance x is being calculated from the center. So the value of x, if you are calculating to the point O, x का value कितना हो जाएगा? 0 हो जाएगा. So if you put x is equal to 0 here in the equation, what is the value of electric field? वो भी 0 हो जाएगा. देख ले, you only said the answer, which means your preparations are going very good मेरा बच्चा लोग. ठीक है? Okay. Moving on. Electric field line. क्या होता है? Very simple. It is the graphical way of representing the electric field at a point. Matlab, we use lines in order to represent the electric field at a point. So we all know that from the positive charges, electric field lines emerges, and to the negative charges, electric field lines will be moving. Matlab, if you take the charges separately, hai na, dekh le. If you take the charges separately, if you are having positive charges, electric field lines ऐसे emerge out. Okay, and if they are negative charges, electric field lines comes inside. ऐसे बस, that's it. और कुछ नहीं, there is nothing bigger than this to learn about electric field lines. Simple सा topic है. Okay. Moving on, properties of electric field lines, which everybody might be knowing, है ना? देख ले. We'll just go back. Now, if you want to find out the electric field at any point, you want to find the electric field at this point, what will you do? You just draw a tangent to the electric field at that point. So tangent to the electric field lines will give you the direction of electric field. Tangent will give us the direction of electric field at the point. First one. First one. Okay. Then what we have? Electric field lines always begins from a positive charge. Just now we have explained, and end on a negative charge. That is also something we know. Then the number of lines leaving a positive charge or entering a negative charge is proportional to the magnitude. Matlab, if you want to know the magnitude of the electric field at a point, what do you just need to check? The density of magnetic field lines. Wherever the density is more, electric field lines will be more. Here, you can see that the electric field lines density is more, which says the electric field is more here. But check here. The density of field lines are less, which simply says the electric field at that point is also lesser. Bas, ठीक है, और कुछ नहीं. Then we know that two electric field lines can never intersect, because if two lines intersect, it will be having two different directions of electric field at that intersection point, which is not possible, right? We all know this. So these are the properties of electric field lines. Now, let me say, notes will be provided to you in the Telegram channel. So it's good, right? Everything will be provided to you. So fikar mat kijiye aap log. Next one, what is called as electric flux. Just now we have learned what is electric field lines. ठीक है? What is electric flux? Total number of, सुन ले, total number of electric field lines passing perpendicularly through an area is simply defined as electric flux. How will we find out? देख ले, here we have an area. Let's say it is having a magnitude of A. For the calculation of electric flux, area is considered as a vector. You all might be knowing, है ना? So what is the direction of area vector? Perpendicular to the surface of area. So the direction of area vector is defined perpendicular to the surface of area. Let's say there exists an electric field in that region. Okay, and the angle between them is theta. So the flux is defined as, देख ले, electric flux is defined as E A cos theta. It's a scalar quantity and it's having a unit of Weber. Okay, very important, just note it down. What is electric flux? E A cos theta. Fine. Before moving to the Gauss law, is everything clear? Can I see the smiling face from everyone? As you all know, we have to cover a lot much of topic. That's why I'm not interacting with you much. ठीक है? But don't feel left out, because this is the time to study, है ना? This is the time to get a bit serious. What do you all say? So rod may always positive? No, it's according to the question, right? Either it can be positive or negative. Okay. Fine. Yes. Okay, so I can see the smiling face from Palak. Devak, Arohi, Sneha, Vanya, right? Okay, then Reet, Pragya, very good, very good. I can see that amazing, cute, awesome smile from all my bacha looks. Okay, fine. Gauss law. What is said in Gauss law? Gauss law tells that, right? If you are having a closed surface, what do you have? If you are having a closed surface, let's say I'm taking a sphere. Can you see it? Can you see this? I'm taking a sphere here. Gauss law says the total electric flux associated with this closed sphere is equal to the total electric flux associated with this particular closed sphere is equal to 1 by epsilon 0 times the charge enclosed. Enclosed matlab whatever is the charge inside this sphere. Let's say I have 1 coulomb charge here, right? I have 1 coulomb charge here, 2 coulomb charge here, and on the outside we are having some 4 coulomb charge. So tell me, what will be the value of total flux? Total flux is equal to 1 by epsilon 0 times the charge enclosed. How much is the charge enclosed? 1 plus 2 plus 4. Is it correct? No, 4 is outside that closed surface. So in the calculation of flux, 1 by epsilon 0 times 1 coulomb plus 2 coulomb, wo ho jayega 3 coulomb. So 3 coulomb by epsilon 0 will be the total flux associated with this particular surface. Okay. Now we know that flux is equal to E vector dot area vector. This particular equation we use when electric field is a constant. Okay. When electric field is a variable, we use a formula as integral E dot dA. So you will find the equation of Gauss law as integral E dot dA is equal to 1 by epsilon 0 times the charge enclosed. Okay. This is the right formula for our Gauss law. Okay, fine. Gauss law is mainly used to find out the electric field at different points, and it is very easy to find out also. Everything? Okay, so we're going to proceed further. We'll look at some of the properties of Gauss's law, which is very important. The electric flux from any closed surface is only due to charge enclosed by that particular surface. Matlab, we should only be considering the charge which is inside that surface. Okay. Second, any charge outside the surface do not contribute to the electric flux. Just now we have told we only have to consider charges inside. Outside charges doesn't have to do with the electric flux associated with that closed surface. Okay. Electric flux does not depend on the shape of the Gaussian surface. समझ में आ गया? मतलब देख ले, you have 1 coulomb charge and 2 coulomb charge. You are considering first a sphere, right? Then you are considering a square later, मतलब a cube. In both the cases, whether the shape of the Gaussian surface is a sphere, whether the Gaussian surface you are considering is a cube, the flux associated doesn't change, isn't it? Dekh le, if you are writing the Gaussian formula for the sphere, flux total is equal to 1 by epsilon 0 times, what is the total charge enclosed? 1 plus 2, that is 3. Now try to write the Gaussian formula by considering this cube. What will be the formula? Total flux is equal to 1 by epsilon 0 times the charge encloses. Dekh le, अच्छे से देख ले, inside this cube also it has the same 3 coulomb charge. So total flux is 3 by epsilon 0 itself, whatever may be the shape of the Gaussian surface you consider. Total flux remain the same, that is emerging from the charges. Simple. That is all about Gauss's law. Now by using the Gauss's law, we are finding out the electric field because of different charge distributions, starting with infinitely long charge to wire. What is the value of electric field? Let's say we are having a point which is at a distance of r. The value of electric field is equal to, I usually write it like this, 1 by 4 pi epsilon 0. So you can have this 1 by 4 pi epsilon 0 as a general term in all the formulas of electric field. 2 times lambda divided by r. You can ask me, sir, ये lambda क्या है? Let's say the total charge on this particular wire is q. Total length of the wire is L. So total charge by total length is lambda. Matlab the charge per unit length is defined as lambda here. Very important, questions can come. ऐसे ही आ जाएगा, मतलब direct questions can come. Okay, fine. Moving on. Applications of Gauss's law. बच्चा लोग, after this particular theory, we are going to start with the questions. ठीक है, MCQs question, assertion, reason type questions are waiting for us. So this is just a theory discussion. Questions are also going to come. So be prepared, everyone. Next, infinite charged sheet. So can you see the sheet of positively charged sheet? Can you all see that? Let's say here we are having a point. This point, let's say. Okay, this particular point. We are not marking the distance because wherever the point is around this infinitely long charge sheet, the value of electric field is going to be how much? Sigma divided by 2 epsilon. wherever it is, whether it is at this point, whether it is at this point, whether it is at this point, at this point, the electric field value is going to be sigma by 2 times epsilon 0. पूछ ले सर sigma क्या होता है, ये sigma क्या है सर, पूछ ले everyone. Sigma is equal to, let's say, total charge on this particular plate is equal to Q. Total area of the plate is A. So total charge by total area is defined as sigma. Okay, charge per unit area. So we are almost at the end of this chapter. Now we are having the sphere, two kinds of spheres, right? One is a spherical shell and the other one is a solid sphere. Small changes are there in the value of electric field. Let's go with it. Let's take a fresh page, I suppose. Okay. Now first let us take the case of a hollow sphere or a conductor. Fine. If you are taking a hollow sphere, charges will only be residing on the surface because that is only available for the charges to reside. Okay. Even if it is a conductor also, we all know that on the conductor charges will not be residing inside the volume. All the charges will be on the surface. That is the reason for both the cases the electric field equations are same. Fine. First, we have a point P which is at a distance of r from the center. Value of electric field 1 by 4 pi epsilon 0. Let's say it have a charge of Q by r square. Second, if it is on the surface, formula 1 by 4 pi epsilon 0 Q by capital R square. Inside we have a point which is at a distance of r. Electric field kitna? How much is going to be the value of electric field? How much is going to be the value of electric field? Jaldi se batao. Okay, what happened to the smile? Why Shraddha is sad here? Nivek, very good. Ritu, Shraddha, Palak, Nokshi, Devak, Sneha, Richa, Sudeep. Very good. It is going to be 0. Inside the shell है ना, the electric field is 0. Simple. ठीक है, हो गया. Next one, before we go to the part of electric dipole, solid sphere. I'm not writing both. Matlab, on an outside point and on the surface, the formula for electric field for a solid sphere is also same. So I'm not going to repeat the same formula over there. Only difference is there. For a solid sphere, which is at a distance of r from it, the formula for electric field inside point, it is not 0. 1 by 4 pi epsilon 0 QR divided by capital RQ. Very important, write it down. Because in a solid sphere, we'll be having the charge distributed inside the sphere. Okay, fine, good. Okay, now just write it down. It is 1 by 4 pi epsilon 0 Q small r, where small r is the distance from the center to the point, by capital RQ. Very important. Okay, moving on. Electric dipole, till here we'll be doing in this chapter and then we'll be moving to the next chapter. Okay. Electric dipole means two equal and opposite charges separated by a distance between them is simply called as electric dipole. Okay. Then here we have to learn about physical quantity which is called as electric dipole moment. What does this electric dipole moment tells you? Electric dipole moment tells how much stronger this given electric dipole is. What is the formula? Charge Q into 2L. Okay, charge Q into 2L. Question: sir, is it going to be a scalar or a vector? It is going to be a vector. Direction from negative charge towards the positive charge. Very important. Fine. Okay. Next, what we are going to do is we are going to find out the value of electric field produced by this electric dipole, which is going to be the last topic from this particular chapter. Do we have the next page? No, we don't have the next page. Then we'll start with the questions. Okay. We have a negative charge, we have a positive charge, and we have a point P which is at a distance of r from the center. ठीक है, मतलब there is a point P in the axial position. Formula for electric field 1 by 4 pi epsilon 0 2p divided by r cube. What is the direction of this electric field? Same as the direction of electric dipole moment. What is the direction of electric dipole moment? Negative to positive. So this itself is going to be the direction of electric field at this point. Now, let's say here we are having a point Q which is on the equatorial position. Formula for electric field K, okay, then P divided by r cube. K is 1 by 4 pi epsilon 0, P by r cube with a negative sign. What negative sign tells? Because the electric field direction is just opposite to the direction of dipole moment. So this is the direction of electric field gonna be. Fine. Okay. Last thing. We are having some point R which is at a distance of R where it makes an angle of theta with the electric dipole. This is some random point, neither axial, neither equatorial. What is the value of electric field? Everyone. 1 by 4 pi epsilon naught, okay, Q, sorry, not Q, P divided by r cube inside the bracket with root 3 cos square theta plus 1. Okay, so this is it. It is very important. Electric field on the axial point, electric field on the equatorial point, and electric field at any random point which is at a distance of r and which makes an angle of theta with the existing dipole. Cool. Is it clear? Okay. Is it clear? Abhilasha, Hitesh, Pragya. Now Pragya is already giving the answer. Very good. Navya, it will be extending up to 2.5 hours at least for this particular 3 chapters, right? Okay. P is electric dipole moment. Dekh le. Arre. My bad. Arre bacha, look. I have written M, which is the sign for magnetic dipole moment. Ye P hai. Vector P. Arre baap re. P. M is for magnetic dipole moment, so it is electric dipole moment. So आपका भैया मतलब me, I thought that we have reached the chapter of magnetism. ठीक है? This is done. So if you all are ready, we can start with the questions. But chalo, questions. Are you all ready for the questions? जल्दी बता. जल्दी. Ready? Questions? Or not ready? Yes, super duper ready. Yes, Deeba, Sudeep, Shraddha, Hype, Nokshi. Okay, very good. Deva, Kavya, Harshit, Palak, Chideva, everybody is ready. Go for the questions. So here we have MCQ questions, okay? And also we have assertion recent type questions. So start giving me the answers in the chat box. Everyone, start giving me the answer. Jaldi se. Okay, let me see what is happening in the chat box. So Devak is going with option B, Vidhi with option D, Harshida with B, Sanya with B, Shikhar with B, Devak is like tan theta, Harshida B, Hidesh, cos. Okay, Shikhar is tan theta. So Devak is like tan theta, sir, nothing more, just confirm it. है ना? ठीक है. So the correct answer is बच्चा लोग tan theta. Shall we discuss? देख ले. Let's read. A charged ball B hangs from a silk thread S. Okay, this is a silk thread and this is a charged ball. Let's say it is having a charge of Q, which makes an angle of theta with a large charge conducting sheet. This is a large charged conducting sheet. This is okay, which is P as shown in the figure. Question is, the surface charge density sigma of the sheet is proportional to. So what is this sigma proportional to? That is what we want to find out. Okay, look into the question. What is the first thing that comes into our notice? This is an equilibrium. If any body is in equilibrium, net force is zero. Mark all the forces. Which are the forces? Bacha log, this positive charge hai na, this positively charged plate will be producing an electric field in this direction, isn't it? So in the direction of electric field, the charges will be experiencing a force. Formula Q into E. No doubts. Charge will be having a mass, so there will be a weight mg downward. String, there will be a tension force. Hai na? Now I am going to resolve this tension force. Ye theta, ye bhi theta. So this will be T cos theta. ठीक है, और ये T sin theta. हो गया. Body is in equilibrium. Upward force will be equal to downward force, which is upward force. T cos theta. Downward force mg. Okay. Force towards left, that is T sin theta, is equal to force towards right, that is Q. Tell me, what is the value of electric field produced by an infinitely long charge sheet? Just now we have discussed. Sigma by 2 epsilon 0. Now we want to find out what the sigma is proportional to. So if this is equation 1, ये equation 2, क्या कर सकता है? 1 by 2 कर ले equation. T cancel, sin by cos, tan theta. Okay. Now dividing on the right hand side, how much it is going to be? Q sigma by 2 epsilon 0 mg. We don't want the entire formula. We only want sigma is proportional to tan theta. Option B, answer. Simple, dimple, right? Next. Where is our next? Here it is. Okay, so 1 minute mera chalo. I'll just give you the options. Give me a minute, okay? So first option, we only want approximated answer, 5 into 10 power minus 8. Option B is 3 into 10 power minus 8. Option C is 9 into 10 power minus 8. And option D is 10 power minus 8. Okay, this much of meters. Okay, in all with meters option. So tell me, which is our answer going to be? Option A, option B, option C, or option D? We want the approximated answer. Khushi, physics is hard. No worries. After the session, you will find it so much easy. Don't worry at all. ठीक है मेरा बच्ची? So बोल दे. उत्तर क्या है इसका बच्चा लोग? What is the answer for this? I'm not able to find answer in the chat box. Nobody. Okay, जल्दी join कर ले प्रीति. जल्दी join कर ले. नीलेश option D. Vijayanti option A, Khushi option D, Asin option C. Very good. But chalo, the correct option is B, which is 3 into 10 power 8. Shall we discuss? An electron with a speed of 5 into 10 power 6. So electron matlab a minus E charge is moving towards the right with a speed of 5 into 10 power minus 6. Okay, not 10 power minus 6, 10 power plus 6. Enters an electric field of magnitude 10 power 3 Newton per Coulomb, traveling along the field lines in the direction that retards its motion. So the electric field is also in the same direction. Value 10 power 3 Newton per Coulomb. How far will the electron travel in the field before it stops? Initially the electrons are having a velocity of 5 into 10 power 6. ठीक है. Question is how far this will be going. Distance is question mark until the final velocity becomes 0. You can ask yourself why the velocity has to decrease. Because bachcha log, on this negative charge a force will be acting. What is the amount of force acting? F is equal to Q into E. We all know that Q is equal to how much? Minus E electronic charge into electric field. समझ में आ गया? Okay, so this negative sign tells that the force acting on this electron is in this particular direction, towards left. So electron is moving towards right and the force is acting towards left. So what is happening? Acceleration or deceleration? Deceleration happens. Formula minus EE divided by M. Force by mass. Acceleration. Now it is done. Acceleration we know. U, V is 0, S is a question mark. Which formula? V square is equal to U square plus 2AS. Simple. So substitute kar le. 0 square is equal to U square is 5 into 10 power 6. 5 into 10 power 6 the whole square. Acceleration is minus 2 times. What is acceleration? Electronic charge, that is equal to 1.6 into 10 power minus 19. Electric field is 10 power 3 divided by mass of electron is 9.1 into 10 power minus 31 into displacement. What is the only unknown? S value. So I'm leaving the calculation to you all, mera bachcha log. So the displacement you will be getting it as 3 into 10 power 8 meters. Not a big deal. Simple. Hai na? One more questions? Okay. Next one. Everyone do it. It's a very simple basic question. Everybody can do. I'll read the question. Electric field in a region of space is given by 5I plus 2J in its vector form. The flux of this field through an area of 1 meter, we are asked to find flux 5. Magnitude of area is given 1 meter square lying in the YZ plane. So this area is lying in the YZ plane. Question, flux. Simple. Jaldi. Amal, this इससे ज़्यादा lengthy question मिल जाएगा आप लोगों को. Let me tell you. Question, answer, anyone? Anyone? Vidhi is going for the option B. Sahavi Khushi is with 5. Sushmilesh is with B. Sneha with A. Shikhar with B. Himanshu with B. Sir 5. Khushi bol rahi, sir it's 5. Harshad 5. Hi P1 is 5. Okay, let me confirm. The correct option is yes, option A 5. Okay, question is what is flux? Write down the formula. Electric field vector not area vector. है ना? ठीक है. What is electric field vector given? 5I cap plus 2J cap dot area vector. Magnitude of area is 1 meter square. Magnitude is 1. Now direction of area vector. How will you find? Area vector is perpendicular to the plane which is containing the area. It is in the YZ plane. Which direction is perpendicular to YZ? X. X is having the direction of I cap. Dot product 5I dot 1I, that is 5. Because 2J dot 1I, it becomes 0. You all know the properties of dot product. So flux is 5 with the unit of Weber. Answer mil gaya. Okay. Next, assertion recent type. Very simple. Go for it. Assertion recent type. Okay. Let me remove this. Going for the assertion recent type, bacha log. Bacha log in the class will be having all kinds of practice, concepts, MCQs, assertion recent type, sub. You are going to be a pro after this class. Everyone, A, Abhilasha, Nivek, Sania, Ritu, Shraddha, Nilesh, then Yashika, Vijayandi, Abhilasha, Susmilesha, Zoya, Ravi, Himanshu, Stanzen, Ritu, Sneha. Very good. Yes. Awesome. The energy of the class is back again. It's option A. Let's read. When bodies are charged through friction, right, there is transfer of electric charge from one body to another. Correct till here. But no creation or destruction of charge. Bilkul correct, right? So it is completely based on what? The conservation of electric charge. Reason is actually explaining this assertion statement. So which one? Option A. Fine. So there we come and end to our first chapter, moving to the second chapter with your permission. Very good. The chat is flooded with the options. A is Khushi, KNT, Abhilasha, Utkarsh. Very good. Yes, it is option Ajit. Okay. Fine. Now it's time to start our next topic, which is next chapter, electric potential. Okay, shall we? Are you all ready? So write the heading as electric potential. Let me tell to all the new students here in the classroom, I'll be sharing the notes in the Unacademy Class 11th and 12th Telegram channel. Those who only want to write it down have to write it down. Others can just listen to the class and just stay there listening to all the concepts. Okay? Fine. Ready for next chapter? Ritu, very good. Here we go. Electric potential. Going with the definition. What is electric potential, bachcha log? It is the work done per unit charge. It is the work done to take a unit charge, matlab 1 coulomb of charge from infinity. Okay, ऐसे we are bringing it to a particular point. How much charge is being done for taking 1 coulomb of charge from infinity to a particular point? That is actually defined as the potential. Okay? Now, how will you write the formula for work done? F dot dx, hai na? F dot dx divided by q is actually the formula for potential. Tell me, if you are having a positive charge q here and if you are bringing a 1 coulomb charge here, in which direction you have to apply the force? In this particular direction. Okay, the applied force is in this direction. Why? Because this 1 coulomb charge will be experiencing a force of q into E in this direction. Hai na? In this direction will be experiencing a force. So the electric force and the applied force are opposite to each other. So if you want, you can write this is equal to negative of F electric dot dx divided by q. Tell me, what is electric force divided by charge? The electric force divided by charge is equal to electric field. So the simple relationship of potential with electric field and displacement is V is equal to negative E dot dx. If you want me to write it here, V is equal to negative integral E dot dx. Very important, super important. Okay. Now from here, if you want to find out the relationship between potential and electric field, what do you have to do? Differentiate on either sides. You just differentiate this equation on either side. What will you get? dV is equal to, if you differentiate integration, that integration will go, right, E dot dx. Okay? E dot dx. Now the value of electric field will be equal to taking this dx to the left hand side. क्या हो जाएगा? dV by dx with the negative sign. So this is equation of electric field. This is equation of potential. Learn one and just understand how you can convert from one equation to other. Don't learn both because you will get confused. Okay? One equation is more than enough. Okay? Okay. Next, moving on. Another part, to find out the potential produced by a point charge. Matlab, you have a charge q here and we have another point P, which is a distance of r. So the potential produced by this chotu charge q at this point P, formula 1 by 4 pi epsilon 0 q by r. Write it down. Simple. Simple, dimple. Fine? Okay. Now I think I don't need to explain you or tell you separately that potential is a scalar quantity. Okay? And its unit is volt. All these things are basic things which you already might be knowing. So that's why I'm not stressing on it. Okay? Fine. Potential due to a group of point charges. Matlab, देख ले, you have a point P, you have a charge Q1. How will you find the potential? You will find the potential by using the formula we just have learned. 1 by 4 pi epsilon 0 Q1 divided by R1. But if this point P is surrounded by more than one charge, let's say here we have Q2, here we have Q3. In this case, what will you do? Very simple. Find the value of potential at the point P produced by Q1. Then find the value of potential Q2 at the point P produced by Q2. Then find the value of potential at the point P produced by Q3 all separately. Then add it just like a numerical value. Matlab, let's say this V1 you are getting as 3. Okay. And this V2 you are getting it as 5. This V3 you are getting it as minus 1. Okay. What is the net value of potential at the point P? that is 3 plus 5 plus the final one is having potential with a negative sign, so -1. 5 plus 3, 8, -1, that is 7 volt. That's it. Fine. This is how you find out the potential in the case of multiple charges. Fine, no doubts. So in the case of electric field, you have to do it by vector method. Here you just have to simply add the values, bas aur kuch nahi. Potential due to an electric dipole. So I hope you do remember all the concepts we have discussed about electric dipole in the previous chapter. Now we'll only be discussing the potential produced by a dipole. Matlab, we are having a negative charge, we are having a positive charge, okay? And let's say length is 2l. We are having a point P which is at a distance of r from the center. The value of potential at this point P, K. How many of you know K? Then P is the electric dipole moment divided by r square. Okay, Kp divided by r square. Now, if it's an equatorial point, let's say the point is marked as Q, potential at the point Q kitna? 0. Then we are having some random point, let's say R, which is making an angle of theta. The value of potential at this point R, 1 by 4 pi epsilon 0 P cos theta divided by R square. Okay, this is it. So Kp by R square. When it comes to equatorial point, we should be happy. Why? Because at that point it is 0. So you can with a smile write that it is 0. And at any random point making an angle of theta. Formula 1 by 4 pi epsilon 0 P cos theta by R square. Fine. Moving on. What is equipotential surface, mera bachcha log? Right? Those surfaces where all the points on that surface is having equal potential. Matlab, if you consider that this sphere is an equipotential surface, matlab ye hai ki at this point potential will be V, at this point potential will be V, at this point potential will be V, at this point potential, matlab all points on that particular surface will be having equal potential value. What is the shape of an equipotential surface for a point charge? It's sphere. Okay, it is a sphere. So the equipotential surface shape for a point charge is sphere. Now, let me ask you, for a line of charge, hai na, what is the shape of an equipotential surface? It is cylinder. Okay, it is cylinder. Now, you should be knowing what is the shape of equipotential surface of various charge configuration according to the question, according to what is there in NCERT, bas, aur kuch nahi. Fine. Moving on. Now, this is very important. Characteristics of equipotential surface. What is equipotential surface? Shape of equipotential surface, just now we have seen. Potential difference between any two points in an equipotential surface is 0. Because all the points will be having the same potential. So potential difference will be 0. If a test charge Q not is moved from one point to another point on such a surface, okay, the potential energy Q naught V remains same. Potential energy is given as Q naught into V. It is going to remain as a constant. Why? V is going to remain as a constant throughout the points on that particular surface. So Q naught into V, which is the total potential energy, is also going to remain as a constant. Bus. Fair. No work is being done by the electric force when the test charge is moved from along this particular surface, because we know that the work is being done for changing potential energy. Work is done for what purpose? For changing potential energy. Potential energy is remaining as a constant. So if potential energy is a constant, change in potential energy 0. Work done 0. Bus. Two equipotential surfaces can never intersect each other. Okay? And the last point, field lines and equipotential surfaces are always mutually perpendicular. Matlab, if you are having an equipotential surface like this, the direction of electric field it will be perpendicular to this equipotential surface. Another important concept, super important. Okay, fine. Relation between field and potential, we already have discussed at the beginning. Remember, potential is equal to negative integral E dot dx. I have explained you in detail. Electric field is equal to minus dV by dx. These 2 points we already have discussed at the beginning of this particular chapter. है ना? और क्या sir? Now, electric potential energy. How many of you already know what is electric potential energy? Tell me, Chalo, how many of you already know, right, what is electric potential energy? Bobby Kumari, very good, already giving the answer. Good. K Q1 Q2 by R, that is a potential energy between two charges, है ना? How does its relation with potential और कोई? Okay, कोई बात नहीं. Now, what was the definition for potential? Potential was defined as work done for taking a unit charge from infinity to a particular point. Electric potential energy is defined as the total work done. Electric potential energy U is defined as the total work done for bringing a given charge Q from infinity to a point. In potential, it was a unit positive charge. Here, it is the total work done in bringing a given charge Q from infinity to that particular point is potential energy at a point. Okay? It is the total work done. Can you substitute this W? देख ले. W is equal to Q into potential. This is another important relationship, that potential energy at a point is equal to Q into potential at that particular point. Very important. ये भी write down कर ले. And I think I have told you, okay, everybody don't have to write it down because I'll be providing the note. Right? Those who are very first in writing the calculation, कर सकता है. Fine. Good. Okay. Moving on. Now, potential energy of a dipole. Now, in the previous chapter, we were supposed to write down the formula for the torque, which we couldn't. Right now, I'll first write down the torque experienced by a dipole. Then we'll go to the potential energy of a dipole. देख ले. We are having a dipole like this. Positive charge, negative charge. Dipole moment of P is in this direction, right? And there exists an electric field also in this direction. So this electric field will be giving a torque on this electric dipole. The formula for torque experience is given by P vector cross the E vector, or by magnitude it is PE sine theta. So the magnitude of torque is PE sine theta. Fine. At the same time, it will also be associated with a potential energy. Formula is minus P dot E. P is the electric dipole moment, E is the electric field present at that particular point. ठीक है? Fine. Then a last point, that work done for rotating this particular electric dipole in this presence of an external electric field value. What did I tell you, मेरे बच्चा लोग? Work done for what purpose? Work done for rotating this dipole from one angle of theta 1 to another angle of theta 2. Formula: final potential energy minus initial potential energy. Final potential energy is minus PE cos theta 2 minus, what is initial potential energy? Minus PE cos theta 1. This is a formula. Okay. Work done, final potential energy minus initial potential energy, and this done. Okay. ठीक है. I hope you all have noted down. We have talked about torque. We have talked about the potential energy. We have talked about the work done. ठीक है. 3 concepts. Then potential due to a charged spherical shell or solid conducting sphere. We all have discussed about how the electric field is, right, for a shell and a sphere. Now we'll be discussing the same for potential. Sphere, radius r, it's a shell. We are having a point P which is at a distance of r. So potential at this point, we all know. What is it? 1 by 4 pi epsilon 0 charge q divided by r. Fine. On the surface, formula 1 by 4 pi epsilon 0 q divided by capital R. Capital R matlab its radius. ठीक है? Here we are talking about a shell or a conducting sphere where in both the cases charges are residing on the surface. My question, for a point which is at a distance of x from the center which is inside, what is the value of potential? Let's say this is a PQR, S is the point. What is the potential at the point S, which is an inside point? Inside point पे potential क्या है चलो जल्दी बोल दे बच्चा लोग. Everyone in the class. Everyone in the class. Nivek says it's 0. Himanshu says it's 0. Palak says it's 0. Nokshi says it's q by 2r. Shikhar, Himanshu, Abhilasha. Are. Now I realize, just now I have realized how much important is this particular class for you, bacha log. Because if a question is asked from here, you all would be getting wrong. It is not 0. Bacha log, the potential for an inside point is same as that on the surface. Matlab k q divided by r. By heart it right now. Okay, it's not 0. Electric field is 0. Potential is not 0. Potential for any inside point for a shell or for a conducting sphere is same as that on the surface. That is kq by r. K is 1 by 4 pi epsilon 0. Very important. So don't make this mistake ever in your examinations. Okay. So write it down. It's super important. Ho gaya? Okay. It's constant. Yes, Bobby. Not 0. Very good. Very good. It's constant. Now understood? Okay. Good. So we are proceeding further. Solid sphere. For solid sphere, for outside point and for an on the surface, the potential value is same as what we have discussed. The only change what we can experience in the case of a solid sphere is for an inside point. If you are having an inside point which is at a distance of r, it is not like the previous case. Here the potential is equal to 1 by 4 pi epsilon 0 q divided by 2r cube. R matlab the actual radius. Inside the bracket 3 capital R square minus small r square. This is the formula. For an inside point which is at a distance of chotu r from the center, where the sphere is having a bada radius capital R, the formula for potential 1 by 4 pi epsilon 0 q by 2r cube 3 capital R square minus small r square. Very important. Okay. So I hope you all are making the corrections in the concept which you already have learned and where you have chotu missed concepts here and there, isn't it? Okay, understood. Shraddha, Jyoti, Deepa, very good, mera chalo. Okay, so let us proceed further. Now some more topics are left, which is properties of conductor and capacitor. So if you all are giving me a thumbs up sign, we can proceed. Okay, so it's a thumbs up sign from everyone, right? Have some more energy. Energy stored. Okay, so everybody is having the energy. Okay, I'll give you 1 minute of time for every one of you to just close your eyes and think about what all topics we have learned right now. Just think about it. Sani, it's very important. Sign convention is very important. In this 1 minute of time, you can ask the doubts here in the chat box also. Ask whatever doubts you have. Okay, so I think everybody already giving me thumbs up and full of energy, which means it's a good to go sign. Hai na? No need of 1 minute. No need of 1 minute of resting time. 30 seconds more. ठीक है, last 30 seconds. No need, Bobby. Okay, ठीक है. Nobody needs. ठीक है. So I think everybody is full on energy. Will go. After this, मतलब we are almost at the end of this chapter. After this, we'll be having one more chapter, which is current electricity. उसके बाद next session is at 7:30, so we can have some rest till then. ठीक है. Properties of conductor. First one, excess charge on the conductor resides on the outer surface. मतलब whatever charge we give to the conductor, all the charges will be residing only on the surface. ठीक है. Which makes the electric field inside the conductor as zero. Important. 2 points we have discussed. Charges on the surface, inside electric field is zero. ठीक है. Moving on. Then electric field lines are normal to the surface. मतलब let's say this is our conductor. ठीक है. Electric field, if you are drawing electric field line to the conductor, electric field line should always be perpendicular to the conductor. Another important property of conductor, very important. Electric field lines will always be perpendicular to the conductor. ठीक है. Then another, if you take any point है ना, देख ले, if you take any point so close to the conductor, the electric field value will be equal to sigma by 2 epsilon 0. Sorry, not 2 is not there, sigma by epsilon 0. 2 was there for plain charge of sheet है ना. So here it is sigma by epsilon 0. Now sigma क्या होता है? We all know that sigma is total charge of the conductor divided by total surface area. बस. Fine. Okay. Third property. Moving on. The potential of a charged conductor throughout its volume is same. मतलब, if you take a point here, if you take a point here, if you take a point here, if you take a point, if you take a point here, here, wherever you take, the potential value is going to be the same. Reason is inside electric field is zero. That's a reason. ठीक है. So wherever you take, the potential is going to be a constant in the case of a conductor. Fourth and very important one, electrostatic shielding. मतलब, if you are creating a small hole, okay, a small space inside the conductor, we can make that space with zero electric field all the time, though there is external electric field in the region. समझ में आ गया? समझ में आ गया? In the region, let's say there is existing some electric field, right? This electric field will not be coming into this vacuum space inside the conductor because this is a conductor. Charges will be redistributed on this particular conductor to produce the net electric field as zero inside this particular region of the conductor. This we call it as electrostatic shielding. ठीक है. इसका नाम है electrostatic shielding. Very important. Okay, super important. Fine. Moving on. Last topic हो गया capacitors. Okay, very last topic. Tell me बच्चा why we are having the capacitor? Capacitor, which is a combination of two conductors. We use it for storing the charges and discharge those charges according to our need. है ना? ठीक है. Let's say the amount of charge that is stored on this conductor is Q, and the potential difference across which we are keeping this plates is V. The capacitance C is defined as Q by V. So capacitance is defined as the amount of charge present on the capacitor plates per unit potential. मतलब, if you provide 1 volt potential difference across this capacitor plates, how much charge will be there on the capacitor plate? That is given as capacitance. In general, in simple words, if we talk about capacitance, means how much of charge intake can a capacitor can have, how much charge can be stored inside the capacitor. That will be directly given by the value of capacitance. ठीक है? Simple. Now, formula for a parallel plate capacitor. मतलब, this plate is having an area of A. This distance is D. Capacitance formula, A epsilon 0 divided by D. ठीक है? Now देख ले, if this capacitor plates are filled by a dielectric constant of K, in that case the capacitance will be equal to K times A epsilon 0 by D. You just have to multiply the dielectric constant of the material given to find out the capacitance in that case. Okay. Now, K times the new capacitance is K times what is A epsilon 0 by D? The initial capacitance. So by adding the dielectric constant, the new capacitance become K times the initial capacitance. ठीक है? With a smile, है ना? हो गया समझ? ठीक है? We are proceeding further. Then another topic from the part of capacitor is series combination of capacitor and parallel combination of capacitors. Right? देख ले, here we are having capacitors connected in series. Formula, you want C1, C2, C3 and C4. The equivalent value of capacitance is given by 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4. Matlab, this is just the opposite of what you see in the case of where? In the case of resistors. ठीक है? Now, if the capacitors are connected in parallel, I say C1 and C2. Formula for equivalent is C1 plus C2. Simple. Not a big deal. ठीक है? समझ में आ गया? Fine. So this is how you find out equivalent capacitance in the case of series and in the case of parallel. One last concept from the part of capacitors with which we'll be winding up this chapter is the amount of energy stored. What is it? The energy stored inside a capacitor. देख ले. You are having a capacitor where the charge is Q. Its capacitance is C. So the amount of charge stored in the capacitor is Q square by 2C. One of the formulas. Now, by using Q is equal to CV formula, you remember Anna, the basic formula. Q is equal to CV formula. If you substitute for either Q or C, we can get different formulas for the same energy. ठीक है? That I am leaving it to you. You can do it according to your convenience. ठीक है बच्चा लोग? Now it's time for the questions. कर सकता है? Are you all ready to do the questions? जल्दी से बोल दे. जल्दी 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 से बोल दे बच्चा लोग. जल्दी से बोल दे बच्चा लोग. The cavity of metal is, yes, electric field at the cavity is 0 Ritu. Very good question. अच्छा. Session will be till almost 5:30, let's say. We have one more chapter to discuss, है ना, which is current electricity. After that, we'll be resuming at 7:30 for our magnetism chapter. हाँ Bobby, you have a doubt. What is your doubt? Okay, jaldi. Are you all ready? Shall we start doing the questions? Dielectric is inserted. Just multiply that with the dielectric constant K with the already existing capacitance. Bus. Ready? ठीक है. Then here you go with the questions, bachalo. I'll just read the questions. ठीक है? I'll just read the question for you all. Two concentric conducting spheres, okay, of radius r and 2r are carrying charges of q and minus 2q respectively. ठीक है? If the charge on the inner sphere is doubled, the potential difference between the two spheres will be. We are not doing anything to the external charge, right? We are just doubling the internal charge. So what happens to the potential difference in that case? That is what we have to find out. Okay. So, अच्छे से कर ले everyone. Take your time and do it and give me the answer. Take your time and do it, but because I don't want to get the answer which you have copied from your end there. So do it because exams are coming, है ना? So I can see Himanshu with option A बोल रहा है, Nokshi with A बोल रहा है. Sudeep is like, sir, it becomes twice. Himanshu D. Khushi Rajak, is it twice? Don't ask me questions back. है ना? My duty is to ask the questions, है ना? What do you all say? मेरा duty है to ask the questions. Your duty is to give back the answer. We did this question in class with the wow. So we are supers, है ना? We are super great. Okay. Now I can see the option. So our correct option is option A. ठीक है. Let's see how this particular question can be done. Now, what you can do is, we can take a general case and do it. मतलब, देख ले, we are having one sphere. Let's give a charge of QA, and we are having external sphere of charge QB. Now, first let us find out what are the potential differences at both the spheres, then make an equation of potential difference in a general way. Then let's see, right? If we make a change in the charge of inner sphere, what happens to the potential difference? ठीक है, everyone. देखिए, starting with the first, finding out the potential difference or potential at this inner sphere. Either this is radius is RA, okay. For the external, it is RB. Tell me, which all charges are there to produce the potential on this point? ये point, let me give it as A. First one, the QA itself, है ना? Formula K QA divided by RA. No doubt in that, isn't it? No doubt in that, I suppose, for everyone in the class. Now I'm going to tell you, at this particular point, potential is also produced by this external sphere. How? You'll be asking. I'll draw the figure separately, you'll understand. This is our external sphere and this is its radius. Tell me, if I take an inside point, what will be the potential? Just now we have learned, for any point inside a hollow shell, the potential is same as the potential on its surface. What is the potential on the surface? K QB by RB. So whatever is the potential on the surface, same is the potential on the inner point also. Similarly, this is an inner point to this sphere which has a charge of QB. So the potential produced at this point is same as the potential produced on the surface. Formula same, K QB, ये formula K QB by RB. ठीक है, done. Now I am taking a point here, marking it as B, which is the point on the external sphere, finding out the potential. It's an obvious thing, right? At this point B, because of QB, matlab because of its own charge, potential will be produced. Formula K QB divided by RB plus this point is an external point for the inner sphere. Matlab the inner sphere will also be producing a potential at the point B. Formula K, the charge on the inner sphere QA divided by distance from the center to the point B. How much? It's not RA, it's RB. Fine. Now finding out potential difference between these two surfaces, VB minus VA. What does cancel? QB by RB get cancelled. So here we have K QA 1 by RB minus 1 by RA. You can simply see that the potential difference depends only on the inner charge, which is directly proportional. So according to the question, if the inner charge is doubled, what will happen to the potential difference? That will also get doubled. समझ में आ गया? समझ में आ गया? Is it clear? Potential difference only depends upon the charge on the inner sphere. If you want, you can learn it as by heart. ठीक है? Because if any questions come like this, right, you can do it. Okay? So moving on, next one. This is also a very important question, बच्चा लोग. This is also a very good question. आप ही कर ले. So read the question properly, अच्छे से, and give me the answer. Answers. Read the question. Okay, I'll give you time to read the question properly and do it. Dielectric constant of metal infinity. Ritu. Sahil is going with option D बोल रहा है. Cook the cookie. Option C बोल रहा है. What a name, है ना? Khushi, sir, confused between A, B, C, D. So there is a simple thing. If you are confused with A, B, C, D, you can go for a walk around your house 4 times. Okay, and whatever your answer comes at that point, that will be the answer. Okay. Abhilasha, Bobby is like giving for the option A. Okay. Shikhar, A. Okay, so I'll just explain. Very simple. Equipotential surfaces are given. Question is, what is the electric field strength? Here you can see that the direction of the electric field is also mentioned in all the options. So first let us go for finding the direction of electric field. Equipotential surface. What are the directions of electric field to the equipotential surface? Just now I have told you, or some moments before I have told you. What was it? Perpendicular to the electric potential is electric field lines. Electric field lines are perpendicular. What is it? Electric field lines are perpendicular to the equipotential surface. So electric field vector can either take downward direction or upward direction, but it cannot have both the directions. So we have to confirm whether it is upward or downward. Tell me. One more thing. In the direction of electric field, the potential decreases. So in this direction is a potential decreasing? No, it is increasing. 10, then it becomes 20, then it becomes 30. So this is not our direction. So the direction of electric field is upward, perpendicular to this equipotential surface. And what is the angle it makes with the x-axis? 30. This is 90. 90 plus 30. It is 120 degree. Simple. Done, done, or done. Okay? Fine. Now just draw this perpendicular line. Okay, that connects between one equipotential surface of 10 and the other equipotential surface of 20. Now from this we can simply find out the value of electric field. You remember? बच्चे लोग याद है क्या ये? Electric field is equal to potential difference divided by the distance between them. E is equal to V by D. Starting पे with integration we did, but here it is a constant value. We don't need integration, है ना? This is 10 volt. अरे बाप रे, ऊपर गया. देख ले. Potential difference between this and this 10 minus 20. How much it is? 10. So potential difference कितना हो जाएगा बच्चा लोग? 10. And what is the distance between them? How to calculate the distance between them? अरे बच्चा लोग, this is 10, this is 20, मतलब the distance between them here is 10. ये 10 है ना? ये 10 है. Now this angle is 30. Is there any method to find out this distance? There is red color distance, which is the distance between two equipotential surface. बिल्कुल. You just take. What do you have to take? Sine 30. Sine 30 is equal to this red distance, which is the distance between them x, divided by hypotenuse. ये 90, ये तो hypotenuse है 10 centimeter, मतलब 0.1 meters. Sine 30 is 1 by 2, so x, the distance between them, is 0.1 by 2. Substitute it here, the distance between them, that is 0.1 by 2, 2 goes up. How much is this? 2 into 10 by 0.1, 200. हो गया काम. Clear? Have a smile, have a smile, have a smile if it is clear, right? Have a smile, bachcha log, have a smile. Now we'll do one assertion reason type question here. Assertion reason type question. Go for it. Everyone, go for it. Assertion reason type. Time for assertion reason type practice. हाँ बिल्कुल मैं साइड पे. Now I know that. Once you are having the class, you don't need me, है ना? You are like, sir, आप बाहर जाओ. We just need the concept. अरे बच्चा लोग, without me concept कैसे आ जाएगा ना? So don't ask me to get out of the class. So Nivek, Shraddha, Sahil, cook the cookie. I like the name, cook the cookie. Vivek B, then Kuki is like A, Bobby A, Ajit, Abhilasha, Jyoti, everyone is A. है ना? Very good. Yes, the correct option is A only. वो चलो देख ले. The potential difference between any two points in an electric field depends only on the initial and final position. बिल्कुल. While we find out the potential difference, we just look at what is the final potential difference. We just look at what is initial potential difference. We subtract, find the potential difference. हो गया. Do you know why? Because potential is equal to negative of E dot EH, है ना? Because here we are finding out the work done by an electric force. Electric force is a conservative force. We all have learned in our 11th chapter. Work done by a conservative force is depends only on the initial and final position. So the potential difference also depends on initial and final position. So let's look at the reason. Electric field is a conservative field, so the work done per unit positive charge does not depend upon the path followed. Just now we have explained. So assertion, reason true, and reason is a correct explanation. मिल गया हमको option. Okay. So next chapter, current electricity. If you all are ready, let me know. We'll start. Till then, I'll sit for 1 minute. ठीक है? My legs are almost numb. Current electricity chapter, it's a love for Sahil. How many of you love current electricity more than electrostatics? आप लोग ही बता दीजिए. 5 minutes break. ठीक है, last chapter है ना ये, which means we'll be resuming after this class at 7:30 है ना? हाँ, 5 minutes break I don't need. I'll take 2-3 minutes break. Sharwari wave optics के बाद चल रहे हैं. अरे we are talking about electrostatics and current electricity. So Sharwari is like, sir, wave optics. हाँ ड्रिफ्ट वेलोसिटी से ही स्टार्ट करो. शिखर मेरा जान ले ले, मुझे इतना ज्यादा क्लास आज है. सो यू आर आस्किंग मी टू सिंग अ सॉन्ग आज. साहिल, यू लव विद करंट. साविदा, गुड इवनिंग. ठीक है. सो आई थिंक आई एम बैक ऑन ट्रैक मेरा बच्चा लोग. वी कैन स्टार्ट. फुल रेडी? मैं भी रेडी. आपका भैया भी रेडी, आप लोग भी रेडी, सब रेडी. ठीक है, शुरू करो. दम. ओके, दम आ गया पानी पीने के बाद. ठीक है, लेट्स कंटिन्यू. Let's continue with the chapter of current electricity, everyone. The flow of charge per unit time is called as current, है ना? I is equal to flow of charge per unit time. So if you find out a large amount of charge flowing for a large amount of time, you'll be getting the average amount of current flowing. If you want the instantaneous value of current, what you have to do? You have to differentiate charge with respect to time. This will give you the instantaneous value of current. Delta Q by delta T will be giving you average value of current. ठीक है. Now this is done. Now regarding drift velocity. But चलो, let's say this is our conductor. ठीक है. Across this conductor, let's say we are providing a potential difference, let's say of E. What happens? Right, the electrons will start moving towards a positive potential. The average velocity with which the electrons moves here, we call it by the name of drift velocity. Formula: negative of E, which is the electronic charge. Capital E is the electric field present across this particular conductor, divided by mass into τ. You'll be asking, ये τ क्या है sir? I'll just tell you. When electrons are moving, right, it will be colliding with the existing stationary molecules present inside, or stationary ions. After one collision with the ions, how much time this electron takes for the collision with the next ion? Matlab, for the electrons to move from this particular ion till it reaches the next ion, how much time it takes? That is simply called as relaxation time too, or in simple words, right? Simple words, the time taken for successive collision for an electron is simply called as relaxation time. Relaxation time. Important. I hope you all have noted it down. Okay? Then we are having an equation which connects the current and drift velocity. Everybody can note it down. Current I is equal to N, which is the number of turns, the number of charged particles per unit volume. I'll just write it down. Chota n hai na? Number of electrons per unit volume. That is small n. Okay, E is the electronic charge. A is the area through which this particular charges are current are flowing, and Vd is the drift velocity. Mera bachcha log. ठीक है? So this is a simple equation which connects the current and the drift velocity. Another important thing. Fine? Okay. Next equation is for current density. Current density क्या है मेरे बच्चा लोग? The current flowing per unit area. That is I by A is current density. We know that current I is equal to NA drift velocity E divided by this A cancel. We can have another equation for the current density here. ठीक है? One more formula that you have to learn is regarding mobility. Okay, ये mobility क्या होता है मेरे बच्चा लोग? Mobility talks about how easily the free electrons can move within a given conductor in the presence of an external electric potential. That is it. Okay, how easily a given charge can flow. Now, if we talk about the equation of mobility, it will be drift velocity by E, which is equal to E tau divided by M. Drift velocity by electric field, which is also equal to E electronic charge tau relaxation time by mass of the electron. So, we can use either of this particular formula to find out the value for mobility. Fine, smile, E, ठीक है, all good. Proceeding further, मेरे बच्चा लोग. Okay. Resistance of a wire. Needless to discuss much about it. How a resistance is actually produced. When we provide a potential difference to the conductor, the electron starts moving. It will be colliding with the stationary ions present there. That collision is giving some resistance to the flow of charges, which is exactly what we call it as the resistance inside a wire during the time of conduction. Okay, fine. Now, how to find out the resistance of a wire? We usually follow the 4-color system scheme, not the 5-color system scheme. We'll be having 4-color system in order to understand the resistance of a wire. First 2 colors here, which will be directly giving us the numerical value. The third color will be giving the numerical value which has to be given on top of 10. Matlab the power of 10 will be given by the third color. And the fourth color will be giving us tolerance, matlab the error limit. This is how you read it. Now you should be knowing what are the numerical values given to each colors. Each color has each numerical value. We should know what it is. है ना? ठीक है. देख ले. I don't think there is anyone who doesn't know this simple method of finding out the numerical value in a simple way. What is it? B.B. Roy of Great Britain has a very good wife. Numbering starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Last colors can be gold, silver and no color, which is for tolerance. Gold has 5% of tolerance, matlab 5% of error. Silver can have 10% of error. And if no color is given, it means there is an error of 20% in the mentioned value of resistance. That is what it means. Fine. ठीक है. Now, देख ले, I'll give you a small example. This is a resistor. Okay. First color is red. Second color, let me say this is blue. Okay. Third color is white. And the fourth one is gold. Question, what is the value of resistance of this particular resistor given? What will you do? Check the first color. Red. What is the value of red? 2. Second color blue. What is blue here? 6 multiplied by. Third color, which is white, third color will tell what is the power of 10. So this 9 is not simply written as 269. It has to be written as the power of 10 here, plus or minus what is here? Gold. So the tolerance limit is 5%. So this is how the color coding works. Okay, this is how the color coding works. Bachalo. Fine. So simple chapter hai. Most of the things are known to you from your chotu classes. Matlab hai na, electrostatics was a new chapter, but current electricity is something which you already know. So nothing more here. Moving on. Formula to find out resistance. If you are having a wire of length L and area A, the resistance R is found to be directly proportional to length and inversely proportional to the area. Converting this equation into proportionality, we multiply it with a constant. That constant is called as resistivity of the material. So equation for R is rho L by A. So you can ask me, बच्चे लोग, sir, ये resistivity क्या होता है? Resistivity talks about the ability of a given material, है ना? Material's strength to resist the flow of charges. मतलब resistivity only depends upon the material. I'll just write it down. It depends only on the material. Okay, and it also depends upon temperature. If either of these things are changed, this resistivity value will also be changing. Else, resistivity is going to remain as a pakka constant. It is going to be fine. Okay. As I have just told you, resistivity value changes with respect to temperature. The equation for the change is, if rho naught is the resistivity at a temperature of T naught matlab a reference temperature. If T naught is the reference temperature and the resistivity at that point is rho naught, and if you are asked to find out the resistivity rho, right, at a temperature of T, the formula is rho, which is the resistivity at temperature T, is equal to rho naught inside the bracket 1 plus alpha T minus T naught. T minus T. You'll all be asking, sir, ये alpha क्या है? Alpha is temperature coefficient of resistance. Temperature coefficient of resistance. Okay, it's a constant that will be given in the question. Again, you can ask me, sir, what does the constant of alpha represent? Constant alpha represent, right, the fractional change in resistivity per unit change in temperature. Matlab, what will be the fractional change in resistivity to the material if we make a unit change in temperature? समझ में आ गया? As resistance is directly proportional to resistivity, देख ले. Replacing resistivity with resistance, you can have the similar formula. Instead of resistivity, you are asked to find out resistance. Just replace resistivity with resistance because they are proportional to each other. They are proportional to each other. Anurag is asking, sir, are you from Bhopal NIT? नहीं, मैं Calicut NIT से हूँ. Is anyone studying at Bhopal NIT आपका? Okay. So इधर तक clear है ना? मतलब we are just discussing the initial part of the chapter of current electricity. Manju Devi पूछ रहे, sir, MCQ कब? Within some seconds we are going to start with. Not within some seconds. After we discuss all the concept, we'll start doing the multiple choice questions. Then assertion recent time. Clear? Yes? Everything clear till this part? No much doubt, I suppose, right? Okay. So we are going to proceed further. Okay. देख ले, Ohm's law. I'm not going to stress on this particular Ohm's law, right? At a particular temperature, the potential difference between the across the conductor is found to be directly proportional to the current passing through it. Everybody knows V is equal to IR, so I'm not going for it in detail. So moving on. V is equal to IR, the graph between them, current and voltage, it will be a straight line. Sabko pata hai. So we are not spending time on it because you already know. Now, electric power. That also you have learned from Chotu chapter, right? The equation for power is equal to formula. Power means energy by time. है ना? That is energy by time. Formulas are VI, V square by R, I square R. Any of the formulas you can use, but by heart only one. Remaining formulas you will get how? By using the Ohm's law. V is equal to IR, substitute in either of this equation, right? You will get the formula for power, different formulas of power. Okay, done. Smile. Okay. One question, pakka, regarding combination of resistors. You all know this particular concept, hai na? Combination of resistors, nothing new to you. But some questions will be so much twisted with big system of resistors where you'll find it a bit hard to, yes sir, to find the equivalent value of resistance. So try to do some problems from the combination of resistors, multiple choice question, important. Fine. Now, resistors in series, formula R1 plus R2 plus R3 plus है ना? I'm not going for it. From your Chotu classes, you started learning. In parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, 1 by R4, it goes on. है ना? सबको ये भी पता है. So let's not stress on that. Wheatstone bridge. This is something which we haven't learned in our Chotu classes. Now let's stress on this, है ना? This particular point. What is a Wheatstone bridge? Can you see one resistor, second resistor, third resistor, fourth resistor, and the fifth resistor, P, Q, R, S, T. Okay, can you see this 5 resistor? This is also a resistor. Okay, this combination of 5 resistors where the potential difference is applied across a point AC, we call that as Wheatstone bridge. This 5 resistors, uska naam hai bachcha log Wheatstone bridge. Now, let's see when will this Wheatstone bridge will be balanced. Or what do you mean by the concept of balancing a Wheatstone bridge? Very simple. Whenever the current passing through this 5th resistor, whenever the current passing through this 5th resistor is equal to 0, है ना बच्चा लोग? Then we call the given Wheatstone bridge as balanced. ठीक है? Whenever the current passing through that is 0, we call the given Wheatstone bridge as balanced. Very important. ठीक है? Now, you can ask me, sir, right? What is the use of having the current passing through the 5th resistor as 0? अरे बच्चा लोग, if the current is not passing through this 5th resistor, you can simply remove this 5th resistor while calculating the equivalent value of resistance. है या नहीं? है या नहीं? हाँ. So whenever we find out that the given Wheatstone bridge is balanced, you can remove this central resistor and we just need to find out the equivalent resistor of the remaining ones. Bas. Okay. Question, sir, how to check whether the given Wheatstone bridge is balanced? It will only be balanced once it satisfied the ratio of, देख ले, P by R, P by R is equal to, देख ले, P by R is equal to Q by S. Once it satisfies this ratio only, we can say that the given Wheatstone bridge is balanced. Very important. Once it satisfies this, it is balanced. If it is balanced, we can remove the 5th resistor and then we can find out aram se the equivalent value of resistance of the remaining. All good? All good? Okay, now we are moving to the part of cells after Kirchhoff law and then a Chotu topic. After that, done. सुरेंद्र सक्सेना, सर आपकी शादी होगी? अरे बाप रे, मैं इतने जोर से चिल्ला रहा हूँ for the past 2 hours. So Surendra doesn't have any doubt. The only doubt he has is, sir आपका शादी हो गया है? नहीं नहीं, ये तो आपको, ओके ठीक है, let's not go for that. हाँ हाँ पीयूष, बिल्कुल बिल्कुल, it will be downloadable, बिल्कुल. टायर्ड हो गया शिखर? अरे थोड़ा और, half an hour more we'll be done. ठीक है, half an hour more done. Sahil, you are having love for all the topics of this particular chapter, I suppose. कोई बात नहीं. Okay, you can 7:30 we have class. This particular session we are almost at the end. Okay, so we are going to proceed. Cell or a battery. But chalo, when we talk about a cell, it is not only with an EMF, it will also be associated with an internal resistance of chotu R. This is how the real life battery is going to be. Now, if you connect this battery, bachalo, across an external resistance of R, what happens? Will we be able to retrieve this entire EMF of the cell? Entire EMF of the cell outside of the cell? Bilkul nahi. Why? Because once the current starts to flow through this particular circuit, dekh le, there will be a potential drop across this R. How much? What is the potential drop formula? Potential is equal to current into resistance. So I into R. From the total EMF which is being provided by the cell, some potential is getting dropped across its internal resistance. So, potential difference available across the ends of the battery is not going to be its own EMF. That will be EMF minus the potential dropped across its internal resistance minus IR. Okay? So, across this the potential is E minus IR, and it is that same potential that will be available for hamara external resistance. Matlab, external resistor, let it be a bulb, let it be a motor, anything. It will not be available with the entire EMF. It will only be given E minus IR value. Okay, this is one important topic. बहुत important topic है ये. Okay, yes. Combination of cells. This is I think a question you can expect. मतलब parallel combination of cells and series combination of cells. देख लें. Cell of EMF E1, internal resistance R1. Cell of EMF E2, internal resistance R2. Formula: net EMF value is E1 plus E2. बस add कर ले EMF E1 plus E2 and equivalent value of internal resistance R1 plus R2. Just add the internal resistance value because resistances are already in series. बस देख ले, EMF is added up once you connect the cells in the same order, negative, positive, negative, positive. But once you connect the cells in the reverse order, the net EMF is going to be E1 minus E2. Internal resistance hold the same formula, which is R1 plus R2, no changes, but the changes only appears in the EMF once they are connected in the opposite fashion. Okay, good. Okay, fine. Okay, so moving on. Combination of cells, we should also be having what? The parallel combination. Everybody listen. Cell of EMF E1, internal resistance R1. Okay. Cell of EMF E2, internal resistance R2. If they are connected together ऐसे, ठीक है, what is the equivalent value of EMF? थोड़ा बड़ा equation है हमारा बच्चा लोग, E1 by R1 plus E2 by R2, the whole divided by 1 by R1 plus 1 by R2. This is one single equation for finding EMF value. ठीक है, and internal resistance value simple है. Just like you find out the resistance of parallel combination of resistors, same formula, 1 by R1 plus 1 by R2. Now, if E1 is equal to E2 is equal to E and R1 is equal to R2 is equal to E. Matlab, if both the cells are same, both have the same EMF and both internal resistance. Let's find out what is the equivalent value of EMF is going to be. E1 by R1 is E by R, E2 by R2 is E by R, 1 by R1 is 1 by R, 1 by R2 is 1 by R, है ना? If all are same. So this is 2 times E by R, this is 2 by R, क्या हो जाएगा? मतलब if cells are connected in parallel and if they have the same value, ठीक है, the equivalent EMF is going to be the EMF of one single cell. This is very important. You all have to write it down. Very important है चलो. Okay, and one more thing that I want to tell you is, now instead of this getting connected in the same fashion, if it gets connected in the reverse fashion, मतलब ऐसे, this is E1, this is E2, this is R1, this is R2. In this case, the formula for EMF is equal to, देख ले, E equivalent in this case is equal to E1 by R1 minus E2 by R2 by 1 by R1 plus 1 by R2. Tell me, when will we use this equation? Once they are connected in the opposite order. Here you have a negative sign in the equation for equivalent EMF. Resistance again remains the same formula. ठीक है? So we are almost at the end of the chapter. Noted along you Palak, wow, good. Then Kirchhoff law, we are left with 2 more topics. After that we are done. ठीक है बच्चे लोग? And after this we'll be starting the multiple choice questions from this chapter. So everyone wait, start writing down all the formulas, ठीक है, and everything whatever is being discussed, because you need all these to solve the multiple choice questions. ठीक है. Kirchhoff law. 2 laws are there, starting with the first law, which is junction rule. Very simple, everybody can understand, है ना? Kirchhoff's first law tells that the sum of the current coming into the junction, matlab I1 plus I2 will be equal to the current leaving the junction, that is I3. I1 plus I2 हो जाएगा I3. बस current coming into the junction is current leaving the junction. हो गया Kirchhoff's first law. Next, the toughest part is Kirchhoff's second law, which is also called as Kirchhoff loop rule or Kirchhoff voltage law, है ना? Let's see what is being told there. Now in the second law, which is also called as loop rule, it says the total potential difference across all the elements in a circuit, if you add it up, है ना, it will be 0. I'll just tell you, देख ले. Here we have a cell, let's say its EMF is E1, another resistance where the potential difference is V1, another resistor potential difference is V2, another cell essay with E3, okay. So we have this is V1, let's say, V1, V2, V3, V4. Matlab, we are having so many elements and components in a circuit. Potential across each of them is V1, V2, V3, V4 and V5. What is said in Kirchhoff loop rule or the second law is that if you add up all these potential differences, hai na, matlab V1 plus V2 plus V3 plus V4 plus V5 is equal to 0, you will get. Right? If you add up all these potential, you are going to get the value as 0. But this is not the important part from the second law or the loop rule. Which is more important? From this particular part, the more important thing is, right, how the potential is changing. That is a more important thing. So start writing down. I'll just tell you. देख ले बच्चा लोग, if you are having a resistor R where a current is passing through this resistor towards right. This is a point A where the potential is VA. This is a point B. This is a point VB. Now, from the point A, if you are traveling towards the point B, right, across a resistor in the same direction of current, what happens? Potential will be changing. Obviously, how much will be the potential change? We know that that is IR. Question is, will the potential be decreasing or the potential be increasing when you move from the point A to B? Array, when you move from the point A to B, potential will be dropping. So from VA, we have to subtract this IR value to get the potential at the point B. समझ में आ गया? From a point, if you are traveling in the direction of the current, potential drops or potential decreases. Learn only this, and the opposite direction, it is plus. Opposite direction matlab plus means if you travel from the point B to A, opposite to the direction of current, potential will be added up. ठीक है? But don't learn both, confusion हो जाएगा, बस यही learn कर ले. ठीक है? This is more than enough. One more thing. From the point A, this is a cell of EMF E, this is the point B. Now, bacha log, if you are traveling from the point A towards the point B, tell me, is the potential will increase or decrease? If this is having a potential of A, will the potential be increasing or decreasing if you move towards right? It increases. So, while motion, if you are moving from negative of a cell to the positive of a cell, potential increases. ठीक है? So these are the 2 points. These are the 2 points you should be remembering about the Kirchhoff second law. ठीक है? Very important this is. If you know this, you can use it for solving any kind of questions. Okay? Yes. And tell me what we are left in this chapter. But chalo, tell me what is the only topic we are left in this chapter. हो गया, ठीक है? Then we'll resume at 7:30. After this, we are having multiple choice question, assertion, recent type, same chapter. Then we'll be continuing at 7:30. Yara, Palak, Sahil, everyone, tell me. No. We are having, अरे बाप रे, meter bridge. भूल गया हमारा meter bridge को. Meter bridge and we are having potentiometer. Then done. Okay. Tell me why we have a meter bridge. Chalo. Meter bridge is used to find out the unknown resistance. है ना? So how it will be? What is the basic structure of a meter bridge? ऐसे between the left gap you will be connecting one resistance, between the right gap you will be connecting another resistance, from the midpoint you will be taking a galvanometer where the other end is connected to the jockey, है ना? ठीक है. Now you will keep on moving this particular jockey until the deflection is 0, isn't it? Let's say at a point the deflection in the galvanometer becomes 0 and you mark this length as L1. ठीक है? So this length we call it as balancing length. Okay, the length on the left of this particular wire where the deflection in the galvanometer becomes 0, वो होता है balancing length. Then we can write the formula of R by X is equal to L1 by 100 minus L1. So by experiment we can find out L1. If R is a resistance, which we already know the value of resistance, X value we can ऐसे ही find कर सकते हैं. Simple. ठीक है? This is the basic working of a meter bridge. I think everybody knows. है ना? Harsh is like, sir, this is a favorite experiment I have in the physics lab. ठीक है. Next is a potentiometer. Why we use potentiometer? Two purpose: for finding EMF of a cell and for finding internal resistance of a cell. ठीक है? देख ले basic structure. So this is our cell of some internal resistance This is connected across a length of a wire L which is having some resistance R. Let's say the potential dropped across this resistance is VR. This entire thing of the potentiometer, we call it as the primary circuit. This is our primary circuit. In the secondary circuit, we are having the cell of unknown value. Let's say E1. It is connected to a galvanometer, then to a jockey. What will you do? You will keep on moving this particular jockey until this shows zero deflection. And let's say L1 is the balancing length you find on this potentiometer wire. What you can write? We all know what we can write. We can write the EMF E1 is equal to lambda times the balancing length of L1. Now you will all be asking, sir, ये lambda क्या है? What was VR? The total potential dropped across this wire. What is L? The total length of the wire. So potential dropped across this resistor per unit length होता है lambda और कुछ नहीं. ठीक है? ये L1 है, ये E1 है. Okay, so E1 is equal to lambda times L1. Now, if you want to compare the EMF of two cells, matlab E1 you got the value, now you replace this E1 with a cell of E2. Similarly, you do the experiment. Okay, galvanometer you start shifting. At some particular point, you will get zero deflection. So at that point of time, you can write EMF in the second case is lambda times L2. Now you can make the comparison. Equation 1, equation 2, divide equation 1 by 2. E1 by E2 is equal to L1 by L2. Okay, done. Done, not a big thing. Okay, one last thing to find out the internal resistance of a potentiometer. And internal resistance by using potentiometer. Question time, last thing. देख ले. मेरा चलो. So here we have the cell of E1, right? You kept on moving it where you get a zero deflection in the galvanometer. You'll write E1 is equal to lambda L1. You got it. After that, what you do? After that, you connect this secondary circuit to an external resistor, right? And now you do the same experiment. Matlab, you keep on moving this particular galvanometer, right? And find out the length at which the galvanometer shows zero deflection. Okay? Let's say it is showing zero deflection at a value of L2. In that case, the internal resistance R values L1 by L2 minus 1 into capital R. समझ में आ गया? Just like usual case, we'll find out the balancing length of cell of EMF E1. Then in the secondary, you'll be connecting an external resistor, do the same experiment, find out the balancing length. Let's say if it is L2, internal resistance of the cell is equal to L1 by L2 minus 1 into R. Okay. Now what is left? बाकी क्या है? बाकी क्या है? Question बाकी है. बाकी क्या है? आ गया with a smile म्यारा. बिल्कुल बिल्कुल बढ़िया. So it's time to do the problems. जल्दी फटाफट. MCQ का टाइम? बिल्कुल. Yes. Okay. Now the question is right in front of you. All can do it and give me the answer. Go for it. I'm looking into the chat box, everyone. I am just gonna sit so that you all can see the question properly. आ गया तो आ गया पलक. So 3 chapters on 1 complete run we have completed till now. चलो. We are super, है ना? Lambda is potential gradient, Harsh. Very good. हो गया? Answers? I can't find the answers, but chalo. Sahil is going with the option A. Miara is also going with the option A. Palak is going with the option A. Nivek don't know. अरे बाप रे, अरे simple है, देख ले चलो. When a resistance of 9 ohm is connected at the ends of a battery, its potential decreases from 40 to 30. मतलब initial potential difference across the battery before external resistance was connected 40 था. I'll just draw it down. Battery with its internal resistance. If it was not connected to any external device, potential difference is given as 40. Tell me what is the formula for potential difference? E minus IR. Is it connected to an external resistor? No. What is the value of current in this case? 0. है ना? So putting current is equal to 0 here. E, है ना? Because I becomes 0. What is the value of V given? 40. So that 40 is actually the EMF of this particular cell. Okay. Second case, cell with its internal resistance is connected to an external resistor of 9 ohms. In that case, potential difference is found to be 30. Simple. Because we all know V is equal to given by E minus IR is equal to 30. E का value कितना? 40. So 40 minus IR is equal to 30. ठीक है? IR का value कितना हो जाएगा? 40 minus 30, 10. So 10 is equal to I into R. How will you find current in the circuit? How will you find current in the circuit? Array total EMF. That is E. Total EMF how much? 40. है ना? So 40 divided by total resistance. ये R and this R in series. So 9 plus 2R. 9 plus 2R into capital R. This is 10. है ना? हो गया. So cross multiply कर ले. Before that cancel these two zeros. So 9 plus R is equal to 4R. Okay. So 3R is equal to 9 and R is equal to 3 ohms. मिल गया? Not a big deal, है ना? छोटू क्वेश्चन था. Give me that smile. Give me that smile, बच्चा लोग. Okay, fine. Okay, very good. Next. I hope you remember that equation we have learned related to resistance and temperature, है ना? वही वाला क्वेश्चन है. जल्दी. Nivek, can you please watch the replay? You will understand. It's not a big deal. छोटा question है. ममता सर आप अच्छा पढ़ाते हो. Thank you. हो गया. Just use all the formulas. मतलब all the values in the formula for resistance with respect to temperature. Bobby Kumari, question is not clear. अरे बाप रे, ऐसे कैसे? Just read the question. Okay, I'll just read the question for you and do it. देख ले. I can't see the answers from anyone. पता नहीं क्या हो गया. Okay, everyone is asking, sir, is it B or is it A? Okay, देख ले. The resistance of a platinum wire at 0 degrees Celsius. So the reference temperature is 0 degrees Celsius and the reference resistance is 5 ohms. Fine. Okay. And at 100 degrees Celsius, matlab when T is equal to 100 degrees Celsius, the resistance is how much? What is the resistance? 10 ohms. This is given in the question. Question ye ki, when the wire is heated to a temperature of T degrees Celsius, which we don't know, the resistance becomes 25, the value of T is. When resistance is 25, temperature, how much? Right? How much is the temperature? Shall we find out? Just write down the formula for resistance. R equal to R naught 1 plus alpha T minus T naught. ठीक है? How much is R? R कितना? In the first case देख ले. R is 10 ohms. Okay. What is R naught? Initial resistance, that is 5. 1 plus alpha T minus T naught, 100 minus 0, how much? 100. Quick math. 10 by 5, 2. 2 minus 1, 1. Alpha is 1 by 100. Simple mathematics. ठीक है? और कुछ नहीं किया मैं. Now, one information is given. Resistance is 25 at some temperature T. How will we do the, or how will we find the value of T? R equal to R naught 1 plus alpha T minus T naught. है ना? R is given as how much? 25. What is the reference temperature बच्चा लोग? 5. 1 plus alpha is 1 by 100. T is chotu T minus T naught is 0. Simple. 25 by 5. 5. This minus 1. 4 is equal to 1 by 100 into T. So T का value कितना? 4 into 100. T का value कितना? 4 into 100. मिल गया उत्तर. 400 डिग्री सेल्सियस. आ गया समझ? आ गया समझ बच्चा लोग? ओके. यस. एक और MCQ. रेडी? नहीं रेडी? नाउ कम 400. साहिल समझ में आ गया है ना? ठीक है. एक और क्वेश्चन चाहिए? नहीं चाहिए? हर्ष आंसर करेक्ट था? बिल्कुल बढ़िया. ठीक है. वेरी गुड. बिल्कुल. ओके. वेरी गुड. नेक्स्ट. ओके. दिस इज अ वेरी गुड क्वेश्चन फ्रॉम द पार्ट ऑफ हमारा व्हीटस्टोन ब्रिज है ना? याद है व्हीटस्टोन ब्रिज? फ्रॉम देयर. गो फॉर इट. अरे पलक, म्यारा, अभिलाषा, साहिल, ममता, नोक्षी. ठीक है. Everyone is like with full of जोश. ठीक है. Go for it. Do this question. I'll just read the question. The resistance in the four arms of a Wheatstone network in cyclic order are 5, 2, 6, 15. If the current of 2.8 ampere enter the junction of 5 and 15, then the current through the 2 ohm. सिंपल सा छोटू सा साइड. ठीक है. मुझे नहीं चाहिए क्या क्लास पे? मुझे नहीं चाहिए क्लास पे. रीदू आ गया समझ? ठीक है. एनीवन आंसर? हस्ता बोल रहा है कि डी. म्यारा इसलिए बी और डी सर. आपको जो लेना है सर आप ले ले. ओके. यस, द करेक्ट आंसर इज डी. पलक. वेरी गुड. हस्ता वेरी गुड. व्हाई क्वेश्चन इज नॉट विजिबल? होना ही चाहिए. ओके. देख ला, आई विल एक्सप्लेन. 4 आर्म्स ऑफ अ व्हीटस्टोन ब्रिज मतलब 5 ohms. हाउ मच इज दिस? 2 ohms. ठीक है. This is 15 ohms and this is how much? अरे 5, 2, 6 and 15 है ना? ये तो 6 ohm है, ये तो 15. देख ले इन cyclic 5, 2, 6, 15. Okay. And a current of 2.8 ampere enters into this. A current of 2.8 enter into this. Question ये कि how much is the current passing through this 2 ohm? बच्चा लोग ये तो व्हीटस्टोन है. obviously there will be a fifth resistor which is unknown, which is not given R, but there is no need of this R. क्यों नहीं? अरे this is in balanced Wheatstone bridge case. देख ले 5 by 15. How much is this? 2 by 6. Is the ratio equal? Yes, 1 by 3, 1 by 3. So there is no need of this particular resistor here. We can just avoid it. Now, question ye ki, what is the current passing through this 2 ohm? But chalo, the current passing through 2 ohm and 5 ohm is the same. Why? Why it has to be the same? Because they are in series. है ना? So we just want to find out the common current passing through this 5 ohm and 2 ohm. That will be our answer. Fine. Okay. Tell me, how can you find out that particular value of current I? How can you find out? Jaldi se bata. You just need to find out the potential difference across both of them divided by total resistance of them. 5 and 2 are in series. So total resistance is 5 plus 2, 7. हो गया इधर तक, not a big deal, है ना? Now, finding V is what is left. मतलब the potential difference across both 5 and 2. देख ले, the potential difference across 5 and 2, potential difference across 15 and 6 are the same because they are in parallel. So, question is, if we can find out the potential difference between this point, which we mark it as V, we can substitute it here and get the answer. Any method? Yes. That we can be simply found out. How? Because the total current coming into this branch is something which we know, and we also can find out the total resistance of this. So V is equal to I total into R total. है ना? What is I total? 2.8. Find out total resistance of this. Simple. 5 and 2 in series. How much? 5 plus 2, 7. 15 and 6 in series, that is 21. So these two resistors are now connected in parallel. And equivalent resistance how much? R1 into R2, that is 7 into 21 divided by 7 plus 21. Done? 21 plus 7, 28. 7 by 28, 1 by 4. So this is 2.8 into 21 divided by 4. Okay, what is left? Udhar substitute kar le the value of V. Done. V is 2.8 into 21 by 4 by 7. Ho gaya. 21 by 7, 3. So 2.8 into 3 by 4, which is हो गया हमारा काम. ओके, डन डनाडन मेरा अच्छा लोग, डन डनाडन मेरा अच्छा लोग. Everyone yell out here in the class, sir, done. समझ में आ गया सब. It was a very beautiful session, was it? Was it a very beautiful session? Yes, Palak, Mamta. आ गया बिल्कुल. Yes, done. Okay. Now how many chapters we have completed? 3 more chapters. How many chapters are left? 4 more chapters. है ना? Are we going to complete that 4 chapters today itself? Yes. At what time? Magnetism we are going to resume at 7:30 मेरे बच्चा लोग, and at 10 PM we have the one shot of EMI and AC. So Abhilasha, loved it. Raki, Sahil, Myara, Asta, very good, awesome मेरा बच्चा लोग. Can you all do one small thing? Huh? When you come for the next class, everyone, I want every one of you to take one friend. Okay? जो आपका साथी होता है ना, friend होता है ना, उसको भी लेकर आ जा. Tell them that together we can prepare for the term 1 in the best way possible. करेगा सब? करेगा ना? अरे hectic days and hard working days will come, but all these hard working days will always be paid off. Okay? Now, बच्चा लोग, don't forget at 7:30 we have our next class, so don't forget. I want every one of you to be there so that together we can complete all these chapters in one single day. Okay, yes, so Miara is like already her 3 friends are there, so just like Miara, everybody can take your friends. Okay, next class 2 chapters of magnetism. Okay, electric charges and magnetism and matter, these 2 chapters will be discussed in next class, which is at 7:30 at 10 p.m. EMI and AC. Okay, then bacha log, you all can make the subscription because offers are going on. Okay, so these are the other batches what you can see for 11th and 12th. Special class ka timetable, how to join the quiz, special class features. Then thank you everyone mera bacha log, right? Okay, thank you everyone, right? Thank you everyone. Moving charges and magnetism, yes, along with magnetism we'll be covering both moving charges and magnetism and matter both. Okay, done. So is there anyone bacha log who haven't liked the session? Jaldi se jaakar like kar liya aapka. Okay, and those who haven't subscribed, you all can subscribe to the channel. Thank you everyone. See you all at 7:30. Okay, bye everyone. Thank you so much. Till then, bye bye. Take